Okay, so this is our first video dealing with assembly code using this system SASM and the specific compiler MASM. And I think I mentioned this previously. The reason we're using this is because it's very similar to a higher level language, even though the language itself is incredibly different, but the ways that Microsoft allows us to handle the language makes our job a little bit easier. So we're using this. Now, in assembly language, even though there's one assembly for every different type of, instruction set that we're using, the concept it's somewhat similar. So in assembler, we have not the same processors we have it in C++ or Java, for example, that there are many different segments within the file that you're using. So I'm using this file here, and I'm going to show you the different segments and the things that we need to put in every program uh, for our labs. So first, you're going to have a description in your code. And let me just say here, everything that follows the semicolon is a comment. You see here in green. So everything in green is a comment. Okay. So the beginning of your code is going to have a segment where you're going to have your name. Not exactly like this. You see, when you read the lab guidelines, you know exactly what I'm talking about. But for now, your name, lab number, and the description. You are always going to include these libraries when you're within your code because we need to do input and output. So this is pretty much like C++. When you do C in and C out, those two those two instructions only work because you include the C++ library that allows for you to have access to those functions. So you're going to include these libraries as they are, right, in every single program. There may be a constant segment, dot constant, and there may be other constants that you have to define here, but at least you're always going to have this null equals zero constants because we will need it for strings. There may be a dot segment question mark. This is for data that you do not initialize. All right, so uninitialized variables. And this is one example. Here's a variable name. This is a variable type. And you don't need to know what this is right now, but in a future video, you'll see what this type represents. And every variable in the dot data question mark segment has to be followed by a question mark. Okay. You will have very likely a data segment. So this is where you would put the variables that you want initialized. So for example, maybe I want to create a variable called data. I'm sorry, y, and it's going to be the word, and I initialize it to 77. Okay. I have another variable called message in. It's a type byte, and it's a string. So every string has to be followed by comma null. Okay. C++ is the same way, and Java is the same way. It's just that those two languages handle that situation for us. In assembler, we have to do it ourselves. So, libraries, dot const segment, maybe dot data question mark segment for uninitialized variables, definitely dot data segment for variables that you want to initialize. And this is the code segment. So the code segment begins with dot code. So you cannot write the code in here, and we don't put the variables inside the code like we do it in C++ and Java and other languages. So here is the dot code segment. Now the dot code segment is always going to begin with main proc. So main procedure. So this is the directive for creating a procedure. So just like C++, int main, here is our main proc. Your code is going to go in between all of this immediately after main proc. Here's your code, all of it. We'll take a couple minutes and explain a little bit. But once your code ends, you are going to always write these things. Okay, so let me show you here. You're going to call this instruction, which is an instruction to stop the screen. Otherwise, you won't see the output that's on the screen. Okay, I'll show you. So call wait message, return 0. So this returns control to the operating system. Without it, we won't leave the output screen. So wait message, return 0, and this is main end procedure. So every time in your .code segment, begin with this, end with main end procedure, and this ends the file. This ends the main procedure, and end main ends the file. Without it, your code is not going to compile. Okay? And then anything after that, if you put anything here, the compiler ignores. It's not like C++. If you put something in there, it doesn't compile. Here, it doesn't care. So once you do that, and I'll show it to you. Once you do that, once your file is ready, you would come here into build this, and then run. And I'll show you in a minute. Now, in this particular code, all I do is, and I won't explain it the details now because this is in a future video, I will output a string, my string to input a number or enter X. I am going to read that number from the user. I'm going to save that value into the variable X. Then I am going to output another string, which is message out, which says the number input was. And then I'm going to stop because my program ends. So this is all this thing does. Okay, so once you've typed in your program and you've ended with these 4 instructions. So every single lab that you're going to write, you're going to have these things. With the exception of it's slightly different when you have a procedure of your own, and we have to do it a little bit differently. But for now, most of the programs will be in this format, will end this way. Okay, once your code is done, you will go to build this. And you see this at the end. If there's a problem, for example, let's say you type something incorrectly, like I did in line 43, when you build, the compiler is going to say, where the problem is, like line 43, and what the problem is. So in this case, the compiler is saying unidentified or undefined symbol CRL. Now, this is carriage return line feed, which is just the equivalent of the C++, print a new line, cout and end line. Okay, so I need this because I want to space my output. All right, so once you're done, again, go to build this, and then you're going to go to run in a new window. Okay, now, but before you do, when you open SASM, and you should have done this when you've done, you've installed SASM and MASM, and I gave you the tester file, you have to remember that under settings, you have to go under build, okay? Under build, you have to make sure that the assembler that you have selected is under MASM. Normally, it's going to be under NASM. That won't work. If you leave it here, right, and I try to build, you're going to get like a zillion mistakes because NASM is a different kind of language or compiler than our compiler. So our code is not going to work for MASM. Okay, so we have to make sure that settings, when you go to build, the assembler is set to MASM. Don't change anything else, just apply OK. and then go back here and build, and then you see build successfully. All right. Once that's done, you run in a new window. Don't build and run because you're going to see this. Program is executing. And if you don't have the settings correctly on your Windows, this is going to be here for a while. So I'm going to stop. And you have to make sure that, unfortunately, the Windows security, as you see here, go to virus and threat protection. Under virus threat protection, manage settings, and has to be off. It is off in my case, so I'm good to go. So then run, not build and run in a new window. When you do that, you see this black screen, which is the operating system giving you access to the command line. So enter X, this is just any value. I'm going to type in 77. This is what you see on line 33. The read-int procedure is now having access to my program and the operating system. So I'm typing in the number, and then I will hit enter, and then I see number input was, which is the two instructions from line 39 and 40, which is 77. And then press any key to continue. The press any key to continue is from line 45, where you see the wait message to continue. If I don't put that in, if I don't put this instruction in on line 45, when I build it, it builds successfully again. And when I run, okay, I'm going to run this. And you see the program doesn't stop, right? I don't have anything to hold that black screen. And then it disappears from us. Okay, in some systems, maybe the person has it set up in such a way that that black screen, the command line screen, stops, and you don't need this instruction right here. But in my system and most systems, we do. Windows won't stop by itself, so we need to have that wait message there to stop us. Okay, so wait message -88, input number was 88, and press any key to continue. So that's the instruction on line 45. And then you just press any key. Okay, so this is the basic shell program that you're going to use. I have uploaded one similar file onto Brightspace that you can use to start your labs, or you can start it from scratch. So you're always going to have a description. You are always going to use these libraries. You're always going to have a constant segment, and you're going to put at least no equals 0 there. You may have a dot question mark segment for uninitialized data. You definitely will have a data segment where you're going to put your variables. You're going to have a code segment, which begins with main proc for procedure. Your code will be in the middle, and then you're going to end your programs with call with message, return 0, main end procedure, and end main. Okay, so this is going to be your shell, and it'll help you in your course and your future labs.